Hi, my name is Hunter. I got toolkit function y equals 1 over x. This is the normal graph for y equals 1 over x. It has two asymptotes, which you see here, here, and here. The domain and range are both the same. They both don't touch 0, and they're all real numbers. There's no x or y intercept, and it does not increase. It's both concave up and concave down. Translations. So as you see here, this is negative 1 over x plus 5 minus 3. To move to the left, you're going to put x plus 5, and it's the opposite. So if it's plus 5, it goes to the left, which is negative. And if it's minus 5, it goes to the right, which is positive. So for moving down and up, you would do y equals negative 1x plus 5 minus 3. So if it's minus 3, it moves down. As you see here in this graph, this teal graph is the original graph, and then I moved it 5 over, and this purple graph is moving it to the left 5. And then moving it down to the orange is what your final answer would be. For horizontal flips, all you do is put a negative in front of the x, and it flips over the y-axis. For vertical flips, we're gonna translate it to the left, or to the right 5, so it'll be easier to see. So first we're going to start off moving it to the right 5, and then you're just going to put a negative in front of the entire equation. And this is what it's going to end up looking like in the purple. So our example is to try and figure out the equation of the following graph. Our original graph is going to look like this. So this graph is both flipped and moved over. So we're going to move over, well first we're going to see if this graph is flipped horizontally or vertically. And this graph is kind of hard to tell because vertically and horizontally look the same when you do it right here. So this graph is flipped, I'm going to say vertically. So we moved over 1, 2, 3, 4, 5, 6. And then you move down 1, 2, 3, 4, 5. So our equation at the end is going to end up being y equals negative 1 over x minus 6 minus 5. And that is toolkit function y equals 1 over x.